I'm very pleased to welcome James Lennox to you all. He's a professor at Pittsburgh in history and philosophy of science. He's mainly worked on biology. He's a very recognized expert on Aristotle. Published and edited several books. Aristotle's Philosophy of Biology, Aristotle and Parts of Animals 1 to 4, and co-edited Philosophical Issues in Aristotle's Biology, Concepts, Theories and Rationality in the Biological Sciences, Being, Nature and Life in Aristotle, Essays in Honor of Alan Gotthelf, and lastly, he's edited a book on Ayn Rand, Metaphysics, Egoism and Virtue, Studies in Ayn Rand's Normative Theory. He has also published on other biological authors, William Harvey, and not least Charles Darwin. So I'm very pleased to welcome James Lennox.
Thank you. It's wonderful to be here. This is my first time not only in Oslo, but my first time in Norway. And I'm very, very excited to be here. The volume Metaethics, Egoism and Virtue is the first volume in the Ayn Rand Society Philosophical Studies series that the University of Pittsburgh Press is publishing. The second volume in that theory, Concepts and Their Role in Knowledge, just was released yesterday and is available on Amazon for just about 30% off the list price. So run out and buy it. Make me rich. Today I'm going to be discussing not the aspects of Charles Darwin's work that people are generally most familiar with, the ideas that Darwin's name is most associated with, particularly the concept of natural selection and evolution by means of natural selection. Rather, I'm going to be focusing on how Darwin came to focus on the particular problem that the theory of natural selection was intended to solve. And in particular, I'm going to be talking partly about the background and context into which Darwin found himself after he went to the University of Cambridge. And in order to do that, I'll have to set some preliminary context, because what I'm interested in is Darwin as the great integrator, the biologist who for the first time was able to integrate a number of generalizations formed on the basis of very wide-ranging natural investigations. And he was able to see abstract connections among those lower-level generalizations and integrate them in such a way as to more or less force the idea of evolution onto absolutely everybody's table. So I'm more interested here tonight in the way in which Darwin convinced the world that a certain kind of slow and gradual evolutionary process was the only way to account for these abstract relationships that he was able to identify. It's an interesting fact that he convinced almost no one in his own lifetime of natural selection. Natural selection was rejected even by his closest associates, such as Thomas Huxley, for example. But he convinced virtually every naturalist. By the end of his life, he could say, there is virtually no one who is not an evolutionist now. Whereas when I started working on this subject, almost no one was. So he realized this was his great achievement. Natural selection, he thought, was a brilliant idea. He was pretty sure it would turn out to be right. He was right, but we didn't have good reason to think that until the 1930s, so it took a very, very long time. So we're going to talk about sort of the young Charles Darwin, how Darwin gets to the point where he's working on this problem. So we're going to go from the beagle, that's a particularly beautiful, idealized picture of it, I think, to On the Origin of Species. And we're going to spend a certain amount of time on the origin of species, but primarily because of the way it looks back on how he achieved what he achieved in that work. Now, for some reason, there's always a delay between the opening screen and the second one. The rest of the screens don't do that. Darwin, especially among philosophers of biology or historians of biology who have been influenced by contemporary philosophy, often criticize Darwin, sort of make fun of him for making comments like this one. I'll just read through this. After my return to England, this is from his autobiography, it appeared to me that by following the example of Lyell and by collecting all facts which bore in any way on the variation of animals and plants under domestication in nature, some light might perhaps be thrown on the whole subject. I worked on true Baconian principles, and without any theory, collected facts on a wholesale scale, more especially with respect to domesticated productions, by printed inquiries, by conversation with skilled breeders and gardeners, and by extensive reading. Now, when people make fun of that, they usually only quote one little bit of this quotation. It's the little bit that runs, I worked on true Baconian principles, and without any theory collected facts on a wholesale scale. That's where someone like David Hull will stop. And he'll say, oh, how silly. Everyone knows that you can't achieve anything on Baconian principles, that you have to have a theory in advance, and that collecting information is only valuable insofar as you're testing some theory that you already hold, and so on and so forth. But notice that it's a real mistake to stop there, because what you see as you read on is that it's a very focused inquiry that Darwin is engaged in, and a very focused set of methodologies that he's using to persecute that inquiry. So this is not willy-nilly random collecting of facts. This is somebody who has already decided that light on the subject of the origin of species might be shed by looking at the way in which varieties are created by people who work with domesticated animals and plants, and by looking for similarities between what's going on there and variation in natural populations. And notice the last little bit tells you that he used printed inquiries. Well, I don't know if anyone here has actually looked at this material, but you can now because of the wonderful Darwin Online site. Darwin had a 21-question questionnaire that he had privately printed and sent to he not only published it in a number of breeders' journals, but he sent it to every breeder that he could get the address of. And the questions, you'll see, are quite pointed, specific questions. You can see that Darwin has puzzles and problems of a very specific kind that he's trying to get answers to from these people. So the problem is the people who make fun of quotations like that neither understand Darwin and what Darwin is up to, nor do they understand Bacon, because in fact, that's Baconian induction. Bacon was not fond of the ants who run around collecting information and don't do anything with it, and he wasn't fond of the spiders that spin ideas out of their own bodies. He was a fan of the bees that take information and organize it according to certain principles and create something beautiful and sweet by means of that. So they don't get Darwin and they don't get Bacon. Now, going to begin with the first two sentences On the Origin of Species, right at the beginning of the introduction. He mentions the beagle, mentions he was on it as naturalist, and he was struck by certain facts in the distribution of the inhabitants of South America and the geological relationship of the present to the past inhabitants. Now notice the quite specific similarity between the next sentence and the passage I just showed you from his autobiography. These facts seem to me to throw some light on the origin of species, that mystery of mystery, as it has been called by one of our greatest philosophers. All right, I'm not going to say anything about this passage now, but I want you to remember it because we will keep coming back to it during the talk. Now, I need to step back to the 17th and 18th century for a brief few minutes to set the context into which Darwin is thrown, if you like, when he decides he wants to pursue a career as a naturalist. After the trial of Galileo, there was a great deal of soul-searching on the part of people who were part of the scientific revolution, who were pursuing careers as natural philosophers, as they would have been called then, but who were deeply religious people. They were all shocked by what had happened to Galileo, but it didn't cause any of them, or very few of them, to give up their religious beliefs. What they hoped for was some kind of accommodation between the beliefs they held on faith and the new discoveries they were making and hoped to make on the basis of scientific method. So their real question was, is there some way, some room for this accommodation between their religious beliefs, their faith, and their scientific ideals? The common root in Great Britain came to be known as natural theology. God's plan was instituted in the world not by constant and random miraculous interventions in nature, but rather by God laying down natural laws at the beginning of his creation, so that he didn't just create a random world, he created a world governed by natural law. And so if you were in the job of trying to discover new natural laws, this was how you accommodated what you were doing as a scientist with your religious beliefs. What you were doing was revealing more and more and more of God's plan. As you discovered more and more and more about the law-like ways in which the world worked, you were learning more about God's plan of creation. The roots of this idea are to be found in works by John Ray and Robert Boyle, especially Robert Boyle's disquisition about the final causes of natural things. Now, many of you will know the name of Robert Boyle. If you did a little bit of chemistry in high school, you probably learned about Boyle's law at some point or another. He's considered to be and rightly, one of the founders of modern chemistry, one of its originators. And indeed he was. But he was also a man who wrote deeply about how to create this accommodation between religious belief, he was a very deep believer, and his scientific activity. Darwin, of course, learns about this way of accommodating faith and reason through the works of William Paley. He is the most probably influential and famous advocate of natural theology, actually wrote a work by that name, Natural Theology, which Charles Darwin was required to study and be examined on when he was at Cambridge. So it's still the primary, especially in Great Britain, the primary way in which this accommodation was hoped to be achieved by people for whom this was important. Carl Linnaeus, from Sweden, was also a primary advocate of natural theology. That quotation, by the way, is by Carl Linnaeus. He was not a modest man. But people know of his work as a classificationist, but if you look at the title of the Systema Naturae, what you'll find is that it has a subtitle that is pure natural theology. The Systema Naturae, the earth's creation is the glory of God, as seen from the works of nature by man alone. So God has created this system, this organization, this order, and I, Carl Linnaeus, and people who follow my method are revealing the order in the natural world. I also study Aristotle, as some of you know, and I'm often fond in my undergraduate classes of quoting Charles Darwin, who said, Linnaeus and Cuvier had been my two gods. He's saying this upon receiving a translation of Aristotle's Parts of Animals. He says, Linnaeus and Cuvier have been my two gods, but they were mere schoolboys to old Aristotle. So Linnaeus was one of the people that Darwin considered to be one of his sort of foundation stones, one of the people from the previous generation that he was building on and working from. All right, so this is the context. Now, here is the problem that arises. Linnaeus, among other things, trains a large number of graduate students who, it's very interesting to look at their works because their PhD dissertations have in big letters Carl Linnaeus on them, or some version of that in Swedish. And then in very small print underneath is the name of the person who wrote the dissertation. So it's all Linnaeus and my students. But these people were trained, many of them, to go on the voyages to discovery that were leaving Europe and traveling to every corner of the world at this point in time. The Beagle was a late comer to something that had been going on for 200 years by the time the Beagle sailed. And very early on, these voyages were not just exploiting voyages, and they weren't just colonizing voyages. They always had naturalists on board to gather information about the environments, the natural, the animals, the plants, the geology, the mineralogy, and so on of all the countries that were visited. And Linnaeus was one of the primary trainers of people for doing this work with animals and plants. Two of his team were on Captain Cook's 2 voyages, for example. The problem is this kind of backfired because what they were discovering was going to undermine the accommodation that people like Linnaeus so much hoped would be achieved, because the order seemed to be an order that required a very different explanation. Okay, so what are the problems? Well, first of all, if you're a believer in God, in his wisdom, creating animals that are perfectly adapted to their environments, then what you would expect as you go from one part of the world to the next is every time you find an identical environment, you're going to find the same animals, because the animals are perfectly adapted to their environments. If you find the same environment, you better not find different animals, because that would mean somebody's not perfectly adapted. So there were all these strange and unusual, imagine somebody in Europe for the first time seeing a duck-billed platypus, for example. What possible environment could that be adapted to? So as these voyages went from one new place to another, they kept turning up organisms that were completely unexpected on the part of the people who had been leaving Europe on these voyages. And it wasn't just that there were random, unusual creatures that kept turning up, but there were patterns which I'll talk about. That'll be what most of the rest of the talk is about. There were patterns in the distribution of these animals and plants around the world that were completely unexpected. And these patterns didn't suggest a creator that set down certain laws about how animals would be created to suit their environments perfectly. These patterns suggested something quite different. Second problem was that one of the things that started to happen in the 18th century, started going in the late 17th century, but really got going in the 18th century, was an absolutely massive worldwide collection of fossils that became more and more and more scientific and principled. And so it wasn't just happening to stumble across the odd fossil every now and then. It was people identifying places that were likely to be fossil-rich beds and then digging down in those beds, finding cliffs that covered many, many, many hundreds of millions of years of Earth's history that were the kind of structure that would lend itself to fossilization, and then systematically studying those and doing it in South America, in Australia, in Indonesia, in Africa, in North America, in Europe. So that by the beginning of the 19th century, Darwin was born in 1809, by then, patterns were beginning to appear in the fossil record that were as disturbing and interesting as what was appearing in the biogeographic distribution of animals and plants. In particular, what was really disturbing was that there seemed to be a continuous history of extinction and a parallel continuous history of creation. So new species were coming along all the time, other species were disappearing all the time. That's at least the way it looked. So if you're going to treat the geological column as a record of Earth's history, then it looks like you're going to have some kind of God-inspired law that is operating continuously through history to continuously remove species that he had created at some previous time and create new ones. Well, okay, maybe you can figure out a way to make that work, but it's getting more and more difficult, as you can see. Also, and Darwin was the person who really, Darwin and Wallace actually, a little bit later than Darwin, was the person who really realized this and recognized it, is there were links, relationships between the patterns that were emerging in the fossil record and the patterns that were emerging in the study of biogeography, in the study of the distribution of animals and plants around the world. So, if there's going to be this accommodation between faith and reason, if we're going to have a view of the natural world as operating according to divinely inspired laws, the divinely inspired laws are going to have to tell a story about the regular production and extinction of species throughout Earth's history, but not just that, why it has the particular pattern and structure it does, and why it's related to the current distribution of animals and plants around the world the way it is. And again, it's not that with a little bit of creativity you couldn't tell some kind of story about this. It's just getting harder and harder and harder to do. America is full of people who refer to themselves as scientific creationists and intelligent design theorists that are still trying to do this. So it's not as if, people with enough faith and a little creativity can't do it. It's just getting really hard. All right, so it's time for Darwin now. I'm going to do this real quick, but a little bit of family history, because Darwin's family is an important part of the story. His grandfathers, on his mother's and father's side, Erasmus Darwin and Josiah Wedgwood, were founders of a group in the late 18th century known as the Lunar Society, There's a great book, by the way, called The Lunar Men by Jenny Unglo that if you enjoy reading great scientific historical biography, I recommend this work. It's a wonderful piece of work. The Lunar Society was a kind of Enlightenment society of free thinkers. Erasmus Darwin was almost certainly an atheist. Most of the members of the Lunar Society were Unitarians. Erasmus Darwin famously made fun of them by saying Unitarianism was a featherbed to catch a falling Christian, which was him making fun of the Unitarians who still needed this very thin religious belief in order to make themselves happy. He said, just give it up, give it up. So Darwin comes from this family. Now, the followers of the Lunar Society were big fans of liberty, and they were fans of, until it went south, the French Revolution. They were fans of the American Revolution. Now remember, they're living in England. Big fans of the American Revolution. This did not make them popular in England. The society included people like James Watt, the inventor of the steam engine, Joseph Black, one of the great chemists of the late 18th century. Benjamin Franklin was a member who visited regularly whenever he was in England. He was in England a lot. Really fascinating group of people. So this is 2 generations before Charles. This is already an enlightened, scientifically looking forward group of people. Josiah Wedgwood is famous, of course, for Wedgwood pottery. This was the first china that was made in using the modern scientific knowledge of chemistry to allow really thin china to be made that was almost impossible to break. You could sort of drop it from this far to the floor and it would hold up. And he was the first person to mass produce china so that the growing middle class in England could afford to have stuff that a generation before only royalty and aristocrats could afford to have. So this was a good family to be born into, I would say. Now, his parents, Robert and Susanna, had 6 children. Darwin was the 5th to be born. Just a little salacious tidbit here. 2 of them married their cousins. So Charles's wife is Emma Wedgwood, and Josiah Wedgwood III marries Caroline Darwin, one of Charles Darwin's sisters. So the family was a little bit inbred, as you might say. But got to be good genes there, right? So. I'm not going to mention Edinburgh. Darwin began his post-secondary school education by thinking he would become a doctor, and he went to, that's what his father hoped, because his father and his grandfather had both been doctors. His time in Edinburgh was a complete wash as far as medicine was concerned, because he learned very soon he didn't want to be a doctor. He thought the practice of medicine at that time was barbaric, and he couldn't imagine doing it. But he became a member of the Plinian Society while he was there, named after Pliny the Elder, the ancient natural history author. And he became friends, and someone kind of mentored him of a man named Robert Grant, who was a follower of Lamarck's, the evolutionist, the generation before Darwin, and probably befriended Charles because of the fact that he was Erasmus Darwin's grandson, because of course Erasmus Darwin was also one of the first evolutionists and wrote evolutionary tracts. So he had very important experience in natural history already when he was 16, 17, 18 years old in Edinburgh, including learning how to use the microscope properly to study the development of marine invertebrates and so on and so forth. Going to have to pass over that part of the history just for time reasons. He went to Cambridge. He entered Christ College in 1828, graduated in 1831, did reasonably well while he was there. He was going to take orders. I mean, he was studying for a degree in divinity. He never actually took orders, so he never actually got the degree in divinity. But that's what he was studying, because at that point in time, you couldn't be a scientist. There was no such thing. You needed a real job, and then you could, unless you were a rich aristocrat, it wasn't, the family was pretty well off, but the father wanted there to be a profession. And a very common profession at this point in time, if you were going to study the natural world, was to be a minister in a little country church, because it gave you lots of free time, plus you were out in the natural world. And so my poor son, he's given up on medicine. He was my hope for the next generation for the medical degree, but we'll train him to be a country parson. That'll do. So what he studies has nothing to do with where he ends up, right? What he's examined on is stuff like the Gospels, a little bit of baby mathematics, John Locke. He studies Paley's natural theology. He does a little bit of Homer and Virgil in translation. But while he's there, again, in the same way that he ignored his medical education at Edinburgh, but learned a huge amount of natural history, same thing happens in Cambridge. Cambridge is in the hands of the first generation of revolutionaries that are trying to transform the educational process at Cambridge into a real training in mathematics, natural philosophy, the natural sciences, as we would say. And don't pay too much attention to the reverends as they pop up here. You couldn't teach at Cambridge unless you accepted Christ into your heart. So anybody that was going to teach at Cambridge had to be a reverend, so that they'll all have reverend before their names, however religious they were. But John Henslow was Darwin's mentor, and he was transforming the study of botany and mineralogy for the undergraduates at Cambridge. He held professorship in both at different times. Darwin became so close to him that his students poked fun at him by referring to him not as Charles or Charlie, but as he who walks with Henslow, because he seemed to always be with Henslow. He also became very close friends with Adam Sedgwick, who was trying to do the same thing for the geology curriculum at Cambridge. Sedgwick becomes kind of maligned in history, unfortunately, because he was a critic of Charles Lyell. Charles Lyell was the defender of uniformitarian ideas in geology, and until recently, that was sort of considered to be the wave of the future in geology. So if you do kind of Whig history, you look back and say, well, the good guy was the guy who does geology the way we do. That was Lyell. But if you look at Sedgwick's criticisms of Lyell, they're very sophisticated. And the challenges that he's giving to Lyell are quite good. So he's come to be known as the defender of catastrophism in geology. And he also was very religious, so you can steal lots of quotes from Sedgwick that make him sound very reactionary and so on. But that's really anachronistic, because you could steal the same kinds of quotes from Lyell, who was also very religious, and it really doesn't make much difference. Sedgwick, however, was the person who trained Darwin to be a geologist. And if you had asked anybody up until 1859 to identify Charles Darwin's profession, they would have said geologist. Or they would have said natural philosopher, but more likely geology, because that's where he first made his reputation as a geologist, as we'll see. He also, while he was at Cambridge, met up with and became close friends with a cousin, William Darwin Fox. And they were both, Darwin had been collecting and mounting and classifying insects since he was a very young boy. He started it when he was 9 or 10 years old and continued to do it. By the time he was in Cambridge, he referred to himself regularly as an entomologist. And he was very proud of the fact that many species in the lists of British insects actually had his name under them as the first identifier of the species. He was very, very proud of that. This is when he was in his early 20s already. And just two sort of examples of why Darwin was actually a natural choice for the beagle. In some popular biographies of Darwin, you'll say, this is where he learned. He learned his biology on the beagle. He wasn't really ready for it, but this thing fell into his lap. And no, he was recommended to the captain of the beagle by his mentor, Henslow. And it was because somebody asked who would be an appropriate person for the beagle. And the first choice actually wasn't Darwin. First choice, Henslow had a brother-in-law named Leonard Jennings, who was an ichthyologist, a specialist in the fish. Darwin actually used him to classify the fish section of the zoology of the beagle when he got back. But he was married, already had children, and was, in fact, a country parson. And going off for 3 years on a voyage around the world in the middle of the 19th century, not a really good thing to do if you're already married and have children. But if you're a young buck like Darwin, who doesn't have any particular attachments and lots of time on your hands, it's a great idea. This is pretty typical of a series of letters that he and his cousin exchange. And he writes underneath the picture there, the insect is more beautiful than the drawing, but as you can see, that's pretty close to professional drawing. And that's just stuck into a letter that he's sending to tell his cousin about the new insect he's just discovered. The classmates knew that he was serious about insect collecting, because this is a caricature of Darwin that was done by one of his favorite buddies at Cambridge. It's got "Go it, Charlie" written in the bottom there. This is making fun of Darwin for two reasons. One is his love of insect collecting, but the other is that he was quite well known around Cambridge as liking to ride to the hounds a lot. He was a horseman, loved horseback riding, loved hunting on horseback. And so this is sort of making fun of Darwin in two different respects. But both of these show you Darwin at a fairly young age already, fairly sophisticated invertebrate zoologist, if you like. Okay, how does Darwin learn about the problem that's going to obsess him for the rest of his life? It comes to be known as the species problem in the early 1830s. He comes to know about it by means of Charles Lyell's Principles of Geology. This is a quotation from volume 2, and from the 11th chapter of volume 2. And it's about that pattern of extinction and creation of species that I was telling you about early. So he says, if the reader should infer from the facts laid before him in the preceding chapters that the successive extinction of animals and plants may be part of the constant and regular course of nature, he will naturally inquire whether there are any means provided for repairing these losses. Is it possible that new species can be called into being from time to time, and yet that so astonishing a phenomenon can escape the observation of naturalists? So what he's saying is, from the fossil record, it looks as if new species must be coming into being all the time. Is there any reason to think it stopped a few thousand years ago? This must be happening now. But can that really could we have missed that? If new species are coming into being, shouldn't we have observed this over and over and over again? And the rest of the chapter actually is about how it's possible that we actually have missed this. So he actually does some rough calculations about how often it might actually have occurred based on how often he's seen new species appearing in the fossil record, and how small a part of the world we've actually explored systematically, and so on and so forth. And he reaches, maybe it does happen, but we've just missed it somehow. He gives no hint of a theory about how it might have come about. But he does say that though people like Humboldt have said this is a mystery into which the natural scientist can't penetrate, His answer is, but this is exactly what geology is all about. Geology is the study of the history of the Earth. And Lyell, in particular, says that it's the study of the history of both the animate and inanimate history of the Earth. So the history of life on Earth is, for him, part of the history of biology. And the only way to study it, geology, and the only way to study it, of course, is through the rocks. So paleontology is, even to this day, you never know. Should I put the paleontologists in the biology department or in the geology department? Where do they belong? Okay, so he is already in the early 1830s saying that it's a natural thing for the natural scientist to explore this question about the origin of new species, how new species originate. And we should start thinking of it as a regular part of the economy of nature, not some miraculous event that happened once in the history of the world and then never happened again. Okay, so Darwin actually took volume 1 with him on the Beagle and was studying it like crazy. He became a convert very quickly to Lyell's approach to geology, which is a very inductive approach. And then he was so excited about it that he asked his sisters to send him volumes 2 and 3 when they appeared. Now, this is not the era of FedEx, folks. He's out there on, you saw the boat. How the hell do you get something sent to you as you're sailing around the world? Well, the British Navy was all over the place in the 19th century, and they had colonies all over the place in the 19th century. He gets volume 2 in the Falkland Islands, as a matter of fact, which, much to Argentina's continuing dismay, is a British island. And volume 3 he got in Montevideo, I believe. Amazingly, he actually gets the 2nd and 3rd volume. So he's reading and studying Lyell's 3 volumes of the Principles of Geology during the whole Beagle voyage. And of course, he's reading this passage. I should mention the first 4 chapters of volume 2 are a very careful and fair presentation of Lamarck's theory of evolution, and then 3 chapters of scathing criticism of the theory. All criticisms that are absolutely valid. I mean, he had Lamarck nailed. If that's your evolutionary theory, Lyell says, I'm having no part of it. It's just not going to work. So Darwin has also seen an evolutionary theory presented and then scathingly attacked by the scientist he probably most admires in the world while he's on the Beagle. So you all know the route, no doubt. What's important, I want to point 2 things out on this map. One is how often he visits islands close to mainlands. So you'll see it here, Tasmania, this is Mauritius, Madagascar, Cape Verde Islands, the Canary Islands, islands here, the Galapagos, of course, and so on and so forth. That's going to be important to the story. The other thing that's going to be important immediately to the story is that there ought to be a dot there, but for some reason the person who did this particular map left it off. That's Cape Town, South Africa, and when Darwin gets to Cape Town, South Africa, they're sort of on their way home at this point. It's 1836. He has a very important meeting, which he tells us about in his diary of the trip. I dined out several days with Mr. McClear, the astronomer, with Colonel Bell, and with Sir J. Herschel. This last was the most memorable event which for a long period I've had the good opportunity to enjoy. Now, why is Herschel mentioned? Why was this such an important event to Darwin? And who is he? What's he doing there? That's him as a very young man. Well, he's the son of the 18th century astronomer William Herschel. And William Herschel had done a star map of the northern hemisphere. And that'll give you a clue as to why Herschel is there. Herschel himself was really a brilliant polymath. He's one of the originators of the technique of photographic production that was used until, you know, these things came along a few years ago. And he also made original contributions to chemistry, optics, botany. He was doing everything. He was one of the people who was responsible for finally introducing the continental method of calculus into Great Britain. Great Britain was still using the fluxions method of calculus into the 19th century. But most important for Darwin is he was also the author of a contribution to a popularizing work of science called the Cabinet Encyclopedia, called A Preliminary Discourse on the Study of Natural Philosophy. Darwin refers to it as a work that gave him a burning zeal to make a contribution to natural science. And it's a work of Baconian methodology, basically. Herschel was one of 4 people that my good friend Laura Snyder has just written a book about called The Philosophical Breakfast Club that included William Whewell, as well as Herschel, and Charles Babbage, the person who put the first computing machine on Earth. And they sat around every Sunday morning and read the works of Francis Bacon. And they referred to themselves as the Philosophical Breakfast Club, and they put a plan in place while they were in Cambridge that they were going to transform science and society in the 19th century before they all died. And they were going to make science a profession that people could be proud to be members of, and take it out of the hands of the few aristocrats that had enough money to pursue this as a pastime. So there's the quotation from Darwin's autobiography. You probably can't actually see it there, but I can expand it just a little bit. So if you look at the top line there, you'll see that it says, this work, and he mistitles it, so you know he's doing this writing from memory. He calls it the Introduction to the Study of Natural Philosophy, which is not actually its name. So Herschel is at the Cape, as I mentioned, because he's completing the project of his father. He wants to have a location that's under British control in the southern hemisphere that he can use to map the stars of the southern hemisphere, and that's what he's doing there. And he's knighted just before he leaves, so he is Sir J while he's there. That's his home. That's the telescope that he set up when he was there. And the Mr. Maclear, the astronomer that's mentioned in that quote of Darwin's, was working with Herschel on this project. And it's interesting that Darwin doesn't refer to Herschel as an astronomer. Herschel is a natural philosopher. He's got much wider interests, and he's got this philosophical, methodological program in mind. All right, now, this is the most sort of important moment for the talk as far as Herschel is concerned. In 1836, in February, just 3 months before Darwin meets him at the Cape, as he's returning to England, he writes a letter to Lyell. Lyell has just sent him a new edition of the Principles of Geology, and he's apologizing in this letter for not thanking him for the gift of the new edition sooner. And he then goes on, by the way, this book is wonderful in many respects, but you've particularly succeeded in adding dignity to a subject already grand by exposing the view the immense extent and complication of the problems it offers to solution, and unveiling a dim glimpse of a region of speculation connected with it. So what is it? I allude to that mystery of mysteries, the replacement of extinct species by others. And he goes on to say, many will think that your speculations about this are much too bold and you shouldn't be talking about this thing. But I think it does need to be talked about. And he says, I think it needs to be talked about in a way that allows people to see that the creator could be responsible for this process in some way or other. So he goes on to say, we are led by all analogy to suppose that he, the creator, operates through a series of intermediate causes, which is code for natural laws. The primary cause, of course, is God. He wrote the natural laws. The secondary causes are the natural laws that operate. A series of intermediate causes, and that in consequence, the origination of fresh species, remember the title of Darwin's book on the origin of species? So here we're talking about the origination of fresh species. Could it ever come under our cognizance, would be found to be a natural, in contradistinction to a miraculous process. Although we perceive no indications of any process actually in progress which is likely to issue in such a result. So all analogy tells us that it will be intermediate causes that are responsible for this process of introducing new species and causing others to go extinct. But we don't have any evidence of such an actual causal process. So that is Darwin's problem put before him. Remember, Darwin dines with him 3 months after he's written this letter, and Darwin has been studying the principles of geology continuously for 3 years up until this point in time. I am absolutely certain, and I'm still looking for a smoking gun, that Herschel and Darwin talked about this, and this is the seeds of Darwin's desire to solve the species problem, right here. Once he discovers that his God, Herschel, is on board, that this is something that natural science needs to solve, it's a problem that needs to be solved, Darwin, I think, decides to solve it. Closest I have to a smoking gun is the first discussion of an evolutionary solution to the biogeographic distribution problem is in a book called The Red Notebook, which Darwin opens literally a week after he's at the Cape while he's still on the Beagle, and continues to make entries into it after he gets back to England. All right, so what is the species problem? I'll review this quickly because I've already mentioned a number of these. There are biogeographically distinct regions around the globe. So the animals around South America have a particular character. The animals around Australia have a particular character. The animals around North America have a particular character, and so on. The regional differences don't have anything to do with adaptation. So every one of these regions has analogous environments. So the regional differences aren't due to adaptation. What goes on within each region in modifying the members of that region, that is adaptation. But the regional differences aren't to be explained by adaptation. The fossils that you find around the world are also regionally differentiated. You find certain kinds of fossils in South America, and they are related to the kinds of animals and plants you find in South America. There are certain kinds of fossils in Australia, and they're related to the animals you find there. Island populations become extremely important to Darwin because they are a strong verification for these regional differences, because the populations on islands are specifically distinct compared, that is, the species are different, but the family relationship is to the nearest mainland. And that becomes a very important data point for Darwin. I say data point, it's a massive generalization, of course. So in terms of induction, what we're talking about here is going from already established very wide generalizations to much, much wider, more abstract generalizations. Darwin realizes that all of these generalizations, as broad as they are, point to genealogical relatedness among the organisms within a particular region. And we'll go into the details of that now. So just very quickly, I want to distinguish Darwin's outer life and inner life. This is what's going on in his outer life, the life that everybody can see during the period after he gets back from the Beagle. He ends up eventually in a home in the village of Down in Kent. That's what it looks like. It's a very nice place. You can go and visit it today. Marries, settles down, eventually has a large number of children, publishes 3 works in rapid succession, all having to do with products of the research that he's done on the Beagle. And you'll notice 2 volumes of geology. The Journal of Researches is interesting. It's based on the private journal that I showed you a page from a few minutes ago. But he actually leaves that passage about meeting Herschel out of the published version. And I'm really curious about that. I have speculations, but I'm not sure why he does that. And he lives at Down House until he dies. So he's there for 40 years, and he doesn't leave all that often, except for medical treatment. Goes and takes water treatments occasionally for various kinds of ailments. The inner life, however, is the species problem. So what he's realized and what he works to integrate is this, that at this point in time, hundreds of thousands of species are known to be currently in existence around the world. There are no fossils representing the modern species, or very few. The fossil record indicates that fossils were introduced in a particular, the organisms were introduced in a particular order. So for example, up to a certain point in time, there are only aquatic species in the fossil record. At a certain point in time, land species begin to appear. You begin to get amphibians and reptiles and so on. At a little bit later point in time, birds or bird-like creatures and mammal-like creatures begin to appear. And if you narrow down your focus into any one of those particular areas, you get similar kinds of patterns of introduction of more and more distinctive. And the closer you get to the top of the geological column, up to the tertiary layer, closer to us, the more the fossils appear like the organisms that are around today. Notice what I'm doing is I'm describing all of this without any theory. I'm just telling you the patterns that are there to be seen. So the question for Darwin is the one that I've bolded here. What natural laws could explain the following things? These patterns of extinction, the origination of new species, and the patterns of that origination. The patterns of similarity and differences between the species that are around today and the ones that have gone extinct. And the patterns of similarities and differences between species in different regions of the globe that we see around us today. He's looking for one theory that can integrate all of that. That's the goal. Now, a recurrent theme, even in the early Darwin, as you'll see, is to argue that a respectful view of the Creator is one that will argue all of this is happening by means of natural laws. It's not happening by miraculous interventions. It's happening by means of natural laws. And that doesn't mean you are impious, because natural laws are divinely instantiated in the world. So, up till this point, that's a view that Herschel and Lyell can accept. And I'll tell you what gives people, I'm not going to talk about this tonight, but what gives people the biggest problems with Darwin's theory who still have a strong religious animus is the ineliminable role of chance in Darwin's theory. The fact that the variations that come along have nothing to do with the needs of organisms. There's no design to the variations that appear. And every one of Darwin's more religious friends balks at that, because if that's true, the fact that there are human beings on Earth is just a completely random fluke. You know, if the right mutations or the right recombinations hadn't come along at the right time in the right environment, we wouldn't be here. But wait a minute, all these people want to say. We are special. God designed things so we would be here. And you can't just claim that he designed these laws and then left it to be a complete fluke whether you'd have human beings on Earth or not. That takes away the special relationship between God and man. And these guys just couldn't deal with that last step. So I'm not going to talk about the theory of natural selection, but the role of chance in that theory is the thing that really troubled people. Like Lyell and Herschel. Herschel referred to Darwin's theory as the law of higgledy-piggledy, which meant there's way too much randomness and chance in that theory. God doesn't work that way. But here's Darwin in 1838 in his Species Notebooks, trying to solve the species problem. The extinction of South American quadrupeds is difficult on any theory. Without, which means unless, God is supposed to create and destroy without rule. But what does he in this world without rule, i.e. without law-like regularity? The destruction of the great mammals over whole world shows there is rule. South American and Australia appear to have suffered most with respect to extinction of larger forms. From observing way the marsupials of Australia have branched into orders, one is strongly tempted to believe one or two were landed and the continents since grown, that is, the population expanded. This will explain the less development of marsupials in South America from presence of Edentata. Edentata and marsupials have been almost destroyed wherever other animals existed. And it's true that when non-marsupial mammals got to Australia, protections had to be put in place really, really quick, because placental mammals tend to make mincemeat of marsupial mammals pretty quickly. The only exception that I know of being the kangaroos, who are so big and strong that it's not a problem. So this is the kind of creature that he's talking about, and this is actually one of the fossil specimens recreated that Darwin brought back from South America. And it's related to the llamas that are there today. So that letter that I showed you of Herschel's, I'll now tell you it became public knowledge and a cause célèbre. Charles Babbage decided to publish it as an appendix to the second edition of his 9th Bridgewater Treatise, a fragment. Bridgewater treatises were treatises of natural theology. I'll show you a quotation from one of them on the frontis page of Darwin's Origin in a minute. Babbage was making fun of them here. He was actually arguing in this Bridgewater treatise that you could imagine the way in which new species were being produced as a kind of operation of an analytical engine that operates the way his computer was supposed to operate. Darwin knows about it, he cites it, And in the last of the species notebooks, the one where he's already discovered natural selection and is now trying to develop his theory, he writes, Herschel calls appearance of new species the mystery of mystery and has grand passage bomb problem. Hurrah! Intermediate causes. Meaning, hurrah! Herschel is on board with the idea that what we should be trying to do is to discover natural laws that explain the creation of new species, the origin of new species. So, but the hurrah means Herschel's going to love what I do. And he's so disappointed when Herschel doesn't like it. It's sad. All right, so now I want to show you the way in which Darwin integrates these facts and characterizes them in the origin, and how much more sophisticated it is than even he could have done 20 years earlier. So this is from the latter chapters of On the Origin of Species. The most striking and important fact for us in regard to the inhabitants of islands is their affinity to those of the nearest mainland without actually being the same species. On the Galapagos, there are 26 land birds, and 25 of these are distinct species, supposed to be created here. Yet the close affinity of most of these birds to American species in every character, in their habitat, gestures, tone of voice, was manifest. So it is with the other animals and with nearly all the plants. The naturalist, looking at the inhabitants of these volcanic islands, distant several hundred miles from the continent, yet feels that he is standing on American land. Why should this be so? And it would be easy to explain if they weren't distinct species. If they were the same species, you could just say, well, the ones that are there were the ones that could somehow get there. The ones that aren't there are the ones that don't have a means of transport. But they're different species. So they aren't American, but they're in the same genera or family of the ones on the mainland. That's the problem. That means new species had to come along, but why would they come along looking so much like the ones on the nearest mainland? So here's fascinating comparison that he makes. I think this is one of the most brilliant insights in the origin. On the other hand, there's a considerable degree of resemblance in the volcanic nature of the soil, climate, the heights, and sizes of the islands between the Galapagos and the Cape Verde archipelago off the coast of Africa. But what an entire and absolute difference in their inhabitants. The inhabitants of the Cape Verde Islands are related to those of Africa, like those of the Galapagos to America. So what he's saying is, if you look at these islands, and if you look on the maps, they're at almost the same latitude, and they're all volcanic islands. They were created probably within a few 100,000 years of each other, so they're of the same age. The environments, because of the geographical location of them, is very, very similar. You can find absolutely analogous environments as you go from the Cape Verde to the, and yet the animals look completely different. So, of course, Darwin is pointing to the fact that this all but screams they have come from there and evolved. They have come from there and adapted to life on these new islands. So the adaptation explains the differentiation on the islands. But what's most important to the argument here is that Darwin recognizes that the genealogical relationship between the mainland organisms and the ones on the island means that there had to be an evolutionary process. Okay, here's a bat problem. Though terrestrial mammals don't occur on oceanic islands, aerial mammals do. Now again, you don't need a theory of evolution to explain why that's true. They can fly there. But you do need an evolutionary explanation to explain why they're not the same bats as on the mainlands. They're related, but different. But also, Darwin is asking, why would the creator, who could create anything anywhere he wanted to, only create winged mammals on these islands. The environments are perfectly suited to any kind of mammal at all. Why only winged ones? Well, the fact that they are the only ones that can get there explains that. But then, why are they endemic species? Why are they species that you only find on these islands and nowhere else? So, give you a couple of examples. These are the two bats that are found only on New Zealand, and these are two that are only found on Mauritius. And they're very different, and they are more similar to bat species that you find on the nearest mainland, and that also explains to some extent why the ones on these islands tend to look more similar to one another, so that the New Zealand ones are different primarily in terms of the length of the tail that they have. They're called the short tail and the long tail bat. Probably the example that everybody gets pretty easily is the fact that all the mammals in Australia that are natural to Australia are marsupial. And there are very few marsupials anywhere else. I actually had a opossum in my yard drinking out of a fountain we have in our yard a few months ago. So there actually is one North American marsupial, and there's a couple in South America as well. But Australia, every niche that's occupied by a mammal is occupied by a marsupial mammal. And that cries out for some kind of genealogical explanation. And then, when you find out that the fossils in Australia are marsupial fossils, so as you go back into the fossils of the mammals, you keep finding marsupial fossils. It really, again, strikes you. And some of them are very weird. Some of the ones that have gone extinct don't look anything like the marsupials that are around in Australia today. And that's one for these massive overbite. Look at these teeth. Okay, so here's how Darwin presents the problem in The Origin. Mr. Cliff, many years ago, showed that the fossil mammals from Australian caves are closely allied to the living marsupials of the continent. In South America, there's a similar relationship in the giant pieces of armor, like those of the armadillo, found in several parts of La Plata. So Darwin found these enormous plates that were huge, and they were just like those that you find in the armadillo today, but about 3 times the size. I was so impressed by these facts that I strongly insisted on this law of succession of types. Professor Owen has since extended the same generalization to mammals of the Old World. We see this same law in this author's restoration of the extinct and giant birds of New Zealand. We see it also in the birds in the caves of Brazil. So you can see what he's doing. He's integrating all of these more narrow generalizations about all of these cases, and he's pointing his readers to the fact that this is one pattern instantiated all over the world. These are not isolated facts. These are, in fact, facts that are instantiating a single pattern. And the pattern is, as Darwin says, some deep organic bond among the inhabitants of these regions. The inhabitants, though they may be peculiar species, are essentially American. We may look back to past ages and we find American types then prevalent on the American continent. We see in these facts some deep organic bond, this is what I love, prevailing throughout space and time. This is the great integration of the biogeographic, spatial abstraction that he's formed and the temporal historical one. And he's saying these are in fact identifying the same organic bond. It's just one of them is looking at it from the standpoint of the history that created it, and the other is looking at the product of that history. So, back to that opening passage. Darwin is solving the mystery of mysteries. Remember in that letter of Herschel's, he said, I'm calling this the mystery of mysteries. And Darwin, in this opening passage of the Beagle, of the Origin, doesn't say who this greatest philosopher is, who's called this problem the mystery of mysteries. I've often pondered that. I don't know whether he never mentions Herschel because he assumes all his readers will know who said that. That seems very unlikely. The Origin was very widely read, and only maybe a few dozen diehard natural philosophers would have actually read that appendix to Babbage's Bridgewater Treatise, I think. So I leave that as a mystery of mysteries, why it is that he doesn't actually tell us who this guy is. But we all now know who it is. It was John Herschel. I wanted to show you the next sentences after that one. On my return home, it occurred to me in 1837 that something might perhaps be made out on this question by patiently accumulating and reflecting on all sorts of facts which could possibly have any bearing on it. After 5 years, I allowed myself to speculate on the subject and drew up some short notes. That's a 1842 sketch of his argument that he writes up, and we have copies of it. These I enlarged in 1844 into a sketch of the conclusions. He calls that a sketch. It's 200 pages long, and he actually gave it to his wife, Emma, and said, if I die before I get this book written, give this to Charles Lyell or one of my other friends and tell them to edit it for publication. So this was something that he was, proud enough of even then. But when you read it and you compare it to the Origin, it's kind of pitiful. The leaps he made in sophistication between them and the Origin are really amazing. And he goes on, these I enlarged in 1844 into a sketch of the conclusions, which then seemed to me to be probable. So again, there's Darwin's sounding the Baconian phrase, right? I patiently collected facts, and after 5 years allowed myself to speculate. And people look at his notebooks and say, no, he was speculating all over the place in those notebooks. In a way, that's true. He actually starts referring to my theory early on in the notebooks, in about the page 50 or 60 on in the second notebook. He starts using the phrase my theory. But when you look at what he's talking about is the idea of this organic bond, this genealogical connection among all species. He doesn't actually hit on a possible mechanism until very late in those notebooks, and that's when he stops writing the notebooks, basically, is once he hits on the answer. So what he means by my theory is this general idea of an organic bond that he thinks is well established by the abstract conclusions that he's reached at this point in time. So, finishing up, the inductive method that I think is at work in Darwin is something like this. He's moving from observing systematic patterns of similarities and differences, many of which, at least at some level of abstraction, have already been reached by predecessors, by people, and he's just gathering them up and integrating them. He's comparing patterns in similarities and differences between different geographical locations. So I've shown you that all over the place. It's the patterns that keep repeating themselves in region after region that he's fascinated by. And he follows the same step in examining the fossil collections from different parts of the world. What he's doing is he's now gradually isolating more and more abstract similarities that he's seeing in these patterns. So I've mentioned the importance of islands here. So he talks about animals in the Falklands, the Cape Verdes, the Galapagos, Tasmania, Malaysia, Madagascar, Mauritius, and so on, and is constantly saying, look at how this same relationship between island populations and mainland populations repeats itself over and over and over again. So he begins the systematic gathering of facts in these notebooks, and what the notebooks achieve by the end of them is this kind of integration of everything he's learned from the Beagle and everything that everybody before him has learned, and he's trying to formulate them at the most sort of general and abstract level he can to get at what's the essence of the patterns here, because that's going to give us the most important clues to what's responsible for the patterns that we've seen. It'll point us towards the causal answers, if you like. So against these critics that say, oh, this Baconian stuff is all nonsense, it's nonsense until you read Bacon and until you see what Darwin is really up to. It really is a kind of Baconian project if you understand what Bacon calls a project. This is very question-guided, focused, active inquiry. He knows the problem he wants to solve going in. He very quickly figures out a whole slew of great questions to ask. But that's not having a theory already in place that you're then just gathering facts in order to test. So that's the sense in which I think he actually is doing what he says he's doing, a kind of Baconian fact-gathering project in this early stage. Okay, I want to finish up just by mentioning, some of you may already know this, but many of you may not. There are two amazing resources for people who I've gotten interested in this subject to pursue with more zeal. The Darwin Online project is basically every edition of everything that Darwin ever published, plus online versions of all of his unpublished notebooks from the Beagle, the species notebooks, both in their raw form, photograph, the original documents, plus modern edited editions of them. Absolutely everything, more stuff than you could look at in a lifetime. But if you actually manage to get through that, then you can go to the Darwin Project, which is Darwin's publications. And I've actually been collecting the books. I now have 18 volumes. We're only up to 1870. We've got another 12 years before he dies. It's probably in published book form going to be somewhere around 30 volumes. But they're putting it online as fast as they possibly can, and it's all open source. The enlightened viewpoint of the people in charge of these sites is the more eyes on this stuff, the better. So it's open to all of you, and go do your own Darwin research. Thank you.
So we go straight on to questions?
Yeah, that's fine. Yeah. Yes?
The fossils, how do they know which ones were more older and which ones were more recent?
Mm-hmm. There's various aspects to that question. One assumption that seemed to be made pretty generally from about the late 17th century on was that the history of Earth has been laid down in sort of constant layers. And so the deeper down you go, the earlier the layer. The layers that are on top were laid down on top of it at a later period of time. But of course, anybody that's done even a little bit of geology knows that because of all kinds of disruptions of the Earth's crust, things can get inverted, tipped, reoriented, and so on and so forth. So you can't rely on that in any rote way. You have to be thoughtful about it. But you can, gradually you will learn how to identify the results of volcanic uplift and earthquakes and so on and so forth. But I think there is an assumption that is pretty solidly in place by the end of the 17th century, beginning of the 18th century, that the closer you get to the surface of the Earth's crust, the more recent the layer is, and gradually by the late 18th, early 19th century, people are beginning to associate different kinds of organisms with different layers. So you actually find people confidently making judgments about, even when there's been a lot of disruption in the geological column in a particular area, they'll identify a particular bit of the geological column that might be twisted or uplifted in some way or other by the species that are in it, by the kinds of organisms that are in it. So I don't know if that gets at the heart of your question or not, but there is an issue of whether that's a legitimate assumption to make, of course, but I think it is. I mean, the way in which most fossilization takes place is by things getting buried by silt and so on and so forth. So there's a very common way in which things get fossilized is that they get buried by material above them, and that gradually gets pressurized in various ways, and gradually the bony material, or at least the organic material, gets replaced by mineral materials of various kinds. And as that gets studied more and more, people become more and more confident about these kinds of judgments.
Could you tell us something about what the principles of Baconian induction, what they're all about? Because I didn't know that.
Right. So this philosophical breakfast club that I mentioned, Herschel and William Whewell and so on, and Babbage, who were hanging around Cambridge in the early 19th century, all of whom were influential on Darwin. They were called the Philosophical Breakfast Club because they were reading Francis Bacon every Sunday morning, the whole time they were at Cambridge. So Herschel and Whewell are the people that Darwin learns his Baconianism from primarily, and they have very different versions of Bacon. Whewell's version is, Whewell is a little bit influenced by Immanuel Kant. The influence, however, is not entirely negative, because what it does is it focuses Whewell on the idea that the crucial step in induction is the formation of an abstract concept that covers all of the phenomena in a particular domain. So he focuses on concept formation as an inductive process, and that's primarily because he's got this influence from Kant that says it's the way our concepts organize the observable phenomena that's important. What the lessons they're learning from Bacon are that Bacon has these things called idols, idols of the marketplace, and there's a whole slew of them. And what they are a list of ways in which various kinds of prejudices, assumptions, presuppositions, and so on and so forth, coming from religious background, coming from your cultural background, so on and so forth, can bias your collection of facts. And so he's got all of this very long list of ways to sort of guard against ignoring important facts because they don't fit with preconceived ideas that you have and so on. So part of it is this negative idea that, of course, the theories that you bring, the ideas from your cultural background, your religious background, your previous philosophical background, can have a biasing influence on observation. But Bacon doesn't think you just sort of treat that as an inevitability. Bacon says we've got free will. We don't have to do that. Here they are. I've identified them for you. Watch out for them. Always watch out in your observing that you're not being, you're not biasing your observations, and you're not sort of altering the way you're observing because of these various idols that tend to take over our minds. On the positive side, it's a fundamental idea that you focus on similarities and differences, and focus on identifying patterns in the similarities and differences. And that really comes out in both Herschel and Whewell. That's an area where they're both Baconians in a very similar way. And so that's a big part of it. But then Bacon has very specific methods that you use in identifying more fundamental natures and causes by studying patterns of similarities and differences. So, for example, he's got an example he uses of a study of the phenomenon of heat. And he says, the first thing you do is try to make a list of as many phenomena as you can think of, however trivial or unimportant they might be. Don't let various biases influence you. Whatever you can come across, however different it might be, that seems to generate heat. Add it to the list. You don't just stop there, because that's not going to tell you anything. The next thing you do is you start gathering together a list of things that share a lot of properties with the things that you've got on your first list, but actually don't produce heat. And you also do things like, instead of doing that, gather up all the things that are as different as the things in your initial list are, but actually do generate heat. And he takes you through step by step in his own investigation of this subject, and shows you how by using these methods you zero in on what is the essence of heat, what really makes things heat generating. So I can't go through all the details, but that's the basic idea. It's not just a matter of looking for similarities and differences among things and then trying to find patterns in those similarities and differences, but there's actually very specific and concrete methods for how to go about doing that. So it will gradually point you in the direction of what the nature of the thing it is that you're studying actually is. So does that help?
Yes.
Good.
Okay, I was wondering, since Darwin is still today very controversial within the religious people, and they still haven't seemed to get his science. I was just wondering, when he reached his conclusions, did he have a breakthrough? Did he ever say or become an atheist, or did he?
Mm-hmm. We know the answer to that. Thank goodness, because in his autobiography there's a 10-page section on the evolution of his religious beliefs, where he tells us.
All right.
Something. That's interesting. I thought there was a slide I was going to show you. The frontispiece of On the Origin of Species has two quotations. One from Francis Bacon, by the way, and one from William Whewell, Bacon's 19th century follower, one of them. That also tells you, Darwin could have chosen any quote he wanted to put there. Those are the two he chooses. So that tells you something about the Baconian influence, I think. But the two quotes are actually natural theology quotes. The quote from Bacon says, you should not, this is paraphrasing, you should not let any conceit prevent you from pursuing as vehemently as you can the study of God's words or the study of God's work, theology or philosophy. So he's saying, the pursuit of one with great zeal doesn't rule out pursuing the other with great zeal. And the William Whewell quote is from his Bridgewater treatise, which is one of these natural theology treatises. And it's basically saying the one thing we know about the way God has created the world is that it operates by natural laws, not by occasional interventions by God into nature. So at that point in time, Darwin is apparently endorsing a natural theological reading of the origin. And he says, at that point in time, that's where he stood. But then he starts getting these criticisms from Asa Gray and from John Herschel and from Charles Lyell, and they're all objecting to the same thing, that God didn't design the variations that natural selection works on. And Darwin says, you wouldn't need natural selection if God were designing the variations. He would just design the right ones, and the organisms would keep becoming adapted. But that's not, in fact, what happens, and every person who takes care of domesticated animals or breeds plants knows this. They cannot create the variations. The variations just come along willy-nilly, and then they do something with them. And he said it's the same with nature. The variations just come along, and natural selection does something with them. And as he realized how important chance, and they forced him to realize how important chance was to his theory. If you read the way the theory is described in the first edition, at the end of it, he says it's all natural laws of inheritance, natural laws of variation, natural laws of selection. And natural law at this point in time couldn't include a stochastic thing like. So you realize when he's first writing the origin, he's not really aware of how important this chance element is in the theory. But he keeps getting pressed by these people, and he realizes eventually, oh, this theory actually is really incompatible, at least with any kind of robust Christianity. I think Darwin to the end of his day remained an agnostic because the one argument that bothered him till the end of his life was the first cause argument. And that has always baffled me because I don't think it's a good argument. I mean, I don't, God was the creator of the universe. Well, and why doesn't there then have to be a creator of God? And why is he the first cause? And why do you need a cause for the universe anyway? Why can't it just be here? But he was really bothered by it to the end of his day. So he never ended up describing himself as an atheist, but he did openly describe himself as an agnostic. And that was a great distress to his wife, who was very religious. She was Unitarian, but she was a deep believer in the thin God that she believed in. She deeply believed in it. And so there was a real kind of problem in their marriage because of that. But yeah, for the last at least decade of his life, he quite openly described himself as an agnostic, but he never got to the point of being an atheist. He kept thinking there might be good reasons to think that it's all here because of some creator. Yeah.
I was just wondering, when they were digging out the fossils and looking back in time, did they realize the time scales? Like how long? Did they have any idea? Or
no, not at first. It kept getting longer. And of course, Darwin's theory implies that it takes a very long time to even evolve one species. And as you get more and more and more depth in the fossil record, and you begin filling in more and more and more of of the gaps in the fossil record, you begin to realize how many new species have come along throughout history, and that sort of pushes the time scale longer and longer and longer, and it's well into the hundreds of millions of years before Darwin dies. But the kinds of sort of geological clocks that we have that depend on various kinds of radioactive decay and so on, that kind of knowledge didn't come along until after Darwin died. So the kind of ability we have to date things in various ways wasn't there. So it was all just a matter of sort of imagining how long it would have had to have taken for all of this to happen. So if you imagine how many changes have to take place for one species to evolve into another species, and you're imagining the kind of slow, gradual process that Darwin was talking about. Darwin thought it would take tens of thousands of generations for one species to evolve into another species, a good, distinct species. And depending on what kind of organism you're talking about, that means, maybe 100,000 years, 50,000 years, 100,000 years. So gradually, based on those kinds of arguments, it gets longer and longer and longer, and people become more and more and more comfortable with talking about actual time frames. But it's just based on extrapolation from Darwin's view of the evolutionary process, really. Is that good?
Did Darwin talk about or mention inductive methodology before he started his collection of material for the work?
There are a lot of discussions in the species notebooks. I'm trying to think if there's anything. The places to look would be his correspondence from the Beagle voyage and the Beagle notebooks. The Beagle notebooks, I've just started really exploring them, and they're hard go. The species notebooks are fun. Darwin's reading everything under the sun. He's his imagination is running wild. They're really fun to read. The day-to-day notebooks from the Beagle are often incredibly boring on the one hand, and often require a weird kind of specialist knowledge, because what you have to do is know how they practiced geology in the middle 19th century. So it's not enough to know how you would do it today. You have to have this historical knowledge about how it was done then in order just to read, because there's all this notation about the sightings he's taking and the measurements he's taking, and I look at it and I have no idea what he's talking about. But there are a few people. Sandra Herbert is probably the foremost scholar on his geology, and she's written a book called Charles Darwin, Geologist. A good place to look for that. But there's lots of stuff in the species notebooks about methodology and a lot of discussion of induction and so on. But before that, I can't think of anything. It's before that that's important, because he's doing this on the Beagle, right? So, the one thing I know is that he read and loved Herschel. He wrote to William Darwin Fox right after he read the preliminary discourse. If you haven't read it immediately. It's extremely exciting. So we know he studied it, and he studied it over and over again, and we know during his, and Lyle discusses inductive methodology in the study of history, in the Principles of Geology, and we know Darwin was reading that on the Beagle. But him actually making his own methodological comments all over the place after he gets back to Great Britain, both in his correspondence and in the species notebooks. But before that, I can't think of anything. Good question. made me want to go.
So is that all the questions?
Don't know.
Thank you. Now, this talk was organized by a student club here, Föreningen för studium av Objectivism. Those who are interested in attending similar talks can sign up. It costs 20 kronor. The next event is tomorrow and Sunday. We have a conference in this same building, Auditorium 2, starting 11, where among others James Lennox will be talking about Aristotle, namely, and axioms.
Yes.
So hope many of you will show up there as well. So thank you very much for showing up today.